Hi all, welcome to another math video. This is Dr. Lennon, and we are going to be looking at my favorite section from the preliminaries, factoring polynomials. So factoring kind of takes P4 and then reverses the process. So we'll be looking to take single polynomial that's multiplied out and rewrite it as possibly several smaller degree polynomials in parentheses. So I kind of think of this as in this section you'll kind of see three main techniques. So let's say three techniques for factoring. So technique number one is the simplest, and it's always the first thing you should look for. Just taking out the greatest common factor, which we abbreviate by GCF. Okay, so let's look at examples of how this works. Basically the goal is to kind of take out biggest number that divides the regular numbers and to smallest common power of x. I'm trying not to use too much fancy terminology to confuse you, so probably after I say something like this, it'll make sense just when we look at a few examples, because I don't want to just introduce terminology for terminology's sake. Okay, so let's look at some examples. So factor out the GCF would be typical instructions. And let's say we had something like 81 x to the fourth power minus 27 x squared. Okay, so then your goal is to just take out the biggest possible thing that you can from the regular numbers. This one we're actually quite fortunate because 27 goes into 81 evenly. 27 times 3 is equal to 81, so we can take 27 out in terms of the regular numbers, and then we can also take out what's the smallest common power of x. That's just going to be the x squared. So we get 27x squared on the outside, then we write a set of parentheses, and then we have to figure out what goes on the inside. So we're really doing the distributive law backwards. So notice 3 times 27 equals 81, so we put a 3 in parentheses. But if I were going to do 3 times 27x squared, I'd just end up with 81x to the second power. So I need to tack on another x squared so that when we multiply x squared times x squared, remember we add the exponents with a variable, so that'll give me 81x to the fourth power. And then 27x squared is already 27x squared, so we just need to account for that negative sign by throwing in a minus 1. So this is factoring by taking out the GCF. Notice the way you always check it is you can just take your number on the outside and go ahead and multiply it back through using the distributive law and make sure you get what we had to start with up here, which in this case we clearly will. Okay, we'll get more practice with these as we go through the learning guide. I just wanted to show you one basic example. The second thing is difference of squares. That's the second big technique. This is kind of like what we did in the previous section, or actually 2 sections ago when we rationalized denominators. So if you remember the conjugate, why was that important? Well, we had a really nice formula for multiplying these things out. So the conjugate formula told us if I had an expression a plus b, and then I have the same exact expression a minus b, we're going to end up with a squared minus b squared. So anytime you see a polynomial and they tell you to factor and it only has 2 terms, I always look for difference of squares right away. So let's do an example of this. Sorry, I'm trying to give myself a little more white space so we're not so crowded. All right, so what's an example? E.g., let's look at factoring a simple one. Let's say something like 4x squared minus 9. So if this is going to work, basically we can kind of set up the precedent. So we're really starting over here on this side of the formula, and we want to work our way over to the left side. So if a squared is equal to 4x squared, notice that's going to make our expression a equal to just regular old 2x. And if b squared is equal to 9, we know the square root of 9 is equal to 3. So when we factor this, we can just write it as 2x plus 3 times 2x minus 3. I've had a lot of questions about students asking me if you could write it as 2x minus 3 times 2x plus 3, and that's completely fine. That's the commutative law of multiplication. If you multiply 3 times 5, it makes 15, but if you would multiply 5 times 3, it would still be 15. So these are exactly the same. And I don't give preference to either one. So if you want to write the top one or write the bottom one, it's the same difference to me. Okay, let's go ahead and move on again to the last technique, which is involves factoring by grouping, we'll say. And for this technique, a lot of people may have alternate methods of doing it, some faster methods where they kind of guess or use a slightly different technique. That's fine. That's fine. Go ahead and do that if you're comfortable. But if you want a more step-by-step process, I think this is a really good way to do it. So we'll just jump in on an example on this one, and I'll kind of show you how it works. So let's say this involves when we factor trinomials. So factor, let's say something simple like 3x squared minus 2x minus 5. Okay, so this step-by-step process is going to kind of have a bunch of different parts. So step 1, what we want to do is multiply first and last numbers. So in this case, we just do 3 times the negative 5. Remember to keep the negative with it. Gives me negative 15. Then the next step is going to involve, we're basically looking to split this minus 2x in the middle up to make this 3-term polynomial a 4-term polynomial where we can make 2 simpler groups. So kind of it looks like we're making it more complex, but it actually gives us a nice way to break down the factors. So let's see what we're going to do here. Well, we want to look for step 2. We want to look for factors of sorry, I'm supposed to be doing this. Factors of number from step 1 that adds to the middle number. Okay, so in this specific case, what we want is factors of negative 15 that add up to the middle number, negative 2. So in this case, that's going to be negative 5 and positive 3, because negative 5 plus 3 equals negative 2. This number up here that we were looking at. Okay, once we have that great number, what are we using it for? Well, we want to split up the middle number, because if you notice, negative 2x is really just equal to minus 5x plus 3x. So step 3 is just to split up the middle term. Normally I won't write all these steps in words, but I figure the first time it's good to go into it in some detail. So what we have is we had 3x squared, let me just remind you of the polynomial, minus 2x minus 5, and we're going to split up the middle term by writing it as 3x squared minus 5x plus 3x minus 5. So notice the minus 5x and plus 3x give us the minus 2x in the middle. So these things are really identical, but for the reasons of grouping, we're going to want to include a little bit more. So fourth step is where we actually factor by grouping. So we have the first group, 3x squared minus 5x, and if you'll notice, this group has a GCF, and then we also have 3x minus 5. So what I do is I always just take out the GCF of the first group, which in this case is x, and then I write down 3x minus 5. Notice if I distribute the x back in, I get 3x squared minus 5x above. And then I copy down 3x minus 5 right after it in parentheses. Do this every time. Don't even think about it. And then that's all you have to do is ask yourself, well, what do I take out of the second group to get that expression? Well, in this case, it's already there, so we just have a 1. Because if you distribute a 1, you get the same exact expression. And then notice that we actually have a GCF between these two complicated terms. And what is that GCF? Well, it's the whole set of parentheses, 3x minus 5. So if we take out a 3x minus 5 on the right, on the left, what I'm going to be left with is just x plus 1. Notice if I distribute this whole monstrosity right here across the parentheses, I get exactly what appears above. And that is just the distributive law in a slightly fancier way. And now at the end of all this work, we have finally done it and factored our trinomial that we started with, 3x squared minus 2x minus 5. So great job if you got that one, and if you were able to follow along. If not, it's okay, because we're going to get plenty more practice in the learning guide, which is where we are off to next. So welcome to the learning guide for P5. So we're going to start out with some easy ones, and they'll get a little bit harder, but I'm going to have to pause for a second, and I'll be right back. All right, welcome back. Sorry, I had to take a quick break there to go grab some coffee. It is my favorite thing in the world, and so good. I don't know if I wasn't a coffee drinker till I got to grad school, but finally I had to break down, and all the long nights of studying, really, I would not have my PhD today if it were not for coffee. That's probably the biggest thing that got me through all those long nights of studying. All right, so let's look at problem 1a, factor 3x squared plus 6x. Well, this is just take out the GCF, nothing else to do. So let's go ahead and do that. Notice you can take a 3 out of 3 and a 3 out of 6. So 3 is the regular number, and the smallest common power of x is just x to the first power. Inside the parentheses, did you guess right? X for the first one and plus 2 for the second. And that is all we have to do. Really nice problem, get our confidence up, make us feel like we can do this stuff. All right, 1b, factor this one. This is just like the last one we did when we were doing factoring by grouping, the last step of the last problem before we jumped into this learning guide. Notice that they both have an x plus 5 in common, so we can actually take out that stuff. And I like to keep it on the right just to remind myself of where it came from. Like I said, it's fine if you write it on the left too, but notice when you distribute this whole x plus 5 business back, I'll get exactly what appears above, and visually it looks the same, which hopefully helps you realize where it came from when you do this. So let me just remind you, if you look at all this stuff and you draw the arrows, you should be able to get back to where you got above. So the distributive law does not necessarily apply to just a single number, also for whole expressions, so it's a really handy-dandy law. All right, here's one we kind of didn't look at when we were doing the intro material, but I'll tell you what, you're going to have no problems with it. And the reason why is we just take two groups here, do the GCF, and sometimes we get lucky and they have a common factor after that step. So let's factor by grouping. What's the common factor of the first group? X to the second power, smallest power of x that appears. Can't take out any regular numbers because the number in front of x cubed is just 1. So then we get x minus 2. Next one, greatest common factor, 5. And check it out, x minus 2, he's back. So then what we can do is we can write x minus 2 on the right, and on the left we've got the x squared plus 5. I don't know. Somehow factoring just feels like it organizes the information so much better to me. Like, you know, physicists have atoms they like to break things down by. Chemists have molecules. Biologists have cells. We have prime polynomial factors. Those are our building blocks of basic algebra. So once you get these things broken down, you can really feel like you've accomplished something. At least I do. It's kind of a weird way to look at it, I'm sure, but here we go. Back to another trinomial, x squared minus 8x plus 15. So first step, multiply the first and last numbers. In this case, it's just 1 times 15. That gives me positive 15. Now I need those factors of 15 that add up to negative 8. So notice, if we have a positive number that we're looking for factors of, we better have both factors negative, because the only way we're going to get a negative middle number and a positive thing we're multiplying to is by getting two negative factors. So let's do negative 3 and negative 5. Notice if you multiply them together, what do you get? Positive 15. And if you add them, minus 3 minus 5, you get negative 8. So we split up the middle number, x squared minus 3x minus 5x plus 15. Pretty easy. Then we form our groups, first group, second group. So we get x minus 3, and then copy down x minus 3 in parentheses again whenever we're doing these trinomials. It'll help. So notice we got to figure out what to take out up top, and we know there's basically a 5 coming out, but check out the signs. If we would multiply back through right now, you get positive 5x and negative 15. So we need to put a minus in the middle so that the signs end up appropriate. And then we factor again. We take out the x minus 3 on the right, and on the left we get x minus 5. And we are all done. 2 beautiful linear factors. Makes my day. All right, what's next? Up, another trinomial. Let's do it. First thing we do, first number, last number. 9 times 2, positive 18. Now we need factors of positive 18 that add up to negative 9. Can you guess what they are? Negative 6, negative 3. Split up that middle term, 9x squared minus 6x minus 3x plus 2. All right. Greatest common factor of the first group. Looks like a 3x to me. Then on the inside we'll get 3x minus 2. Copy it down again, 3x minus 2. Then we just got to figure out what to take out of the second group. Same numbers, that's all that happened was the sign change. So we get 3x minus 2 on the right, and 3x minus 1 on the left. Did you get that one? Hope so. Alright, factor 9x squared minus 25y squared. Well, as you can guess, this is going to be one of these a squared, b squared ones, the difference of squares. So a squared is 9x squared, so that makes a equal to 3x. B squared looks like 25y squared, so that tells me that b is just 5y. So once you got a and b figured out, this is a piece of cake. We just do 3x plus 5y times 3x minus 5y. It's just important to remember which one is A and which one is B, which one comes first, which one comes second. Once you got that, easy peasy. Alrighty, let's see what's next. I'm in as much suspense as you. Not really, I've already done this 2 times for my face-to-face classes, but that's alright. Never hurts to do a bunch of problems over and over again. That's really the best way to get good at math. Just do these over and over and over again. Okay, so this one looks a little tricky because the numbers are so simple. But if you multiply the first and last number, you get 1. And the only way to break down 1, where you're going to get to multiply it, is basically 1 times 1. And guess what? 1 plus 1 equals 2. So this one is really pretty basic, and somehow somehow that makes it more confusing sometimes. Look at this, x squared plus x plus 1. But we just carry on with the same process, and remember, even if we don't see a number in front, there's always a 1 there. All right, first one, we got a GCF, x. We can make it x plus 1. And then copy down x plus 1. It's already there, so we just put a plus 1 in front to remind us. Guess what? This one broke down very nicely into x plus 1 times x plus 1. Good job. Sometimes you'll see the answer maybe on my math lab is x plus 1 squared, because remember, this just repeated twice. So you can write it even simpler like that. All right, what is next? Another trinomial to factor. Somehow over here for these pencil problems, you might see them giving you a bunch of formulas like, oh, look at this, a squared minus 2ab plus b squared equals this. I don't notice those when I'm factoring. I just always use the same procedure of factoring by grouping, and it just gives me less to think about, and I just jump right in. So I recommend that. If you want to memorize more formulas, by all means, but I think this is nicer. So 9 times 1 gives me the top number, and I needed to add up to minus 6. Well, minus 3 and minus 3 do the job. So I split up the middle term, 9x squared minus 3x plus 1. First factor, I can take out a 3x, and I get 3x minus 1. Copy down 3x minus 1 again, and I notice that I'm just going to have to take out a minus 1. So I end up with 3x minus 1 times 3x minus 1, or 3x minus 1 squared. All right. Well, it's fun. What do they have for us next? Okay, so for some of these, sum of cubes or difference of cubes, you will need to know a formula. It's not the easiest one to just factor off the cuff. But here's what I recommend. When you come across them in the homework, just hit view an example, and it'll tell you the formula. Normally, what I would do is I just look up the formula. I don't have them all memorized. Or I derive it, but that's a little more complicated. And I won't be asking any of these on the test, so you don't really have to worry about them. But it's good to know that there are formulas for some of these more complicated factors. It works the same way as difference of squares. So let me scroll over to the left here, and we'll see this sum of cubes formula. So let me write this up here just to remind us. It's a to the third power plus b to the third power, and it breaks down like a plus b times a squared minus ab plus b squared. Okay, so let's mosey on back over here, and here's what we're going to do. We're going to do it the same way we did the difference of cubes. So what is our a cubed going to be in this case? A cubed is going to be x cubed. So this is our formula. And basically, to figure out our formula, we want to figure out a, we want to figure out b, a squared, ab, and b squared. So a cubed is x cubed. So that makes a equal to x to the first power. How about b cubed? B to the third equals 27. So we can take the cube root of 27 and figure out that b is equal to 3. Now let's figure out a squared. A squared will just be x squared. B squared will be 3 times 3, or 9. And then AB will give us 3 times x, or 3x. Okay, so to actually factor this one, that's all we have to do is basically copy and paste into the formula. So a plus b is going to be x plus 3 And then our next one, we have a squared, so that's x squared, minus ab, so minus 3x, and then the last term is plus b squared, so plus 9. And that's it. One question you might have is, well, can I factor this trinomial? Because a lot of times we've been factoring things that look just like that. Well, the thing you do to check is you look at the first times last, 1 times 9, and are there any factors of positive 9 that add up to negative 3? And the only things you can really try are negative 3, negative 9, negative 1. And none of those work out, so this one doesn't factor. So sometimes we call it a prime polynomial. One of our building blocks. Oh man, that coffee is so good. Okay, so all done with this one. Let's keep it on moving. All right, this one looks like a cube minus a cube, and over here to the left we have this formula, and I'll write that down up here again. But it's going to be the same technique as last time. A cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So that's the formula. Let's move on back. If you ever want to, like, you don't believe it or something like that, what do? We use the ETOTFT technique that we learned in section P4, and you just come up here and multiply this expression out, and you'll see you'll get a bunch of cancellation, and we'll just end up with a cubed and b cubed, or a cubed minus b cubed. But how about this one? Well, we have a to the third power. That's looking like 8x to the third in the problem we have at hand. And then b to the third power, that's just looking like regular old 1. So that makes regular a equal to 2x. Cube root of 8 is 2. Cube root of x cubed is x. And regular old b equal to 1. So a squared gives me 4x squared. And b squared is just 1. So our b line is pretty simple this time. How about ab? A times b in this case is just 2x times 1, or 2x. So we get the factorization. I'll write it down here. A minus b, 2x minus 1. And then more complicated part, 4x squared, a squared, plus ab, so that's plus 2x. And then the last term, plus 1. And again, if you check 4 times 1, there's no factors of 4 times 1 that add up to positive 2. So we're all done with factoring this one. Okay. So let's move it on down. Look at the next one. So 7 is a little more complicated. We have yeah, it looks like maybe we could do difference of squares, maybe not. But again, remember, the first thing you should always do is there a greatest common factor? Is there any common factor at all? And if so, we should try and take that out. Well, right away, I noticed that both regular numbers are divisible by 5, and they both have a y squared in common. So that leads me to believe that we should start with a GCF. So let's go ahead and take out 5y squared. And inside the parentheses, I'll have 4y squared minus 9. And then if you look at this one, I can do difference of squares. A squared is equal to 4y squared. And b squared is equal to 9. So I can rewrite this as 2y minus 3 times 2y plus 3. And that's it. So a two-step factoring problem using a bunch of the stuff we already know, combining two of the techniques. All right. Move on down to this one. This one looks a little complicated. But what I would recommend doing on something like this is maybe split it up into groups and then try to factor. So I kind of see the idea that they're going for now. This one's not so easy. I don't think I'd ever ask you one like this on a test. But if you notice the first group, we're going to be able to factor that because we can find factors of 1 times 36 that add up to negative 12. And then probably after we factor this, it's going to end up being something squared, and we'll get a difference of squares scenario. So let's just over here kind of in scratch work go ahead and factor the x squared plus minus 12x minus 36 part. Plus 36, excuse me. So our regular number would be 1 times 36, and we can see right away that if we do minus 6 and minus 6, that adds up to minus 12. So this gives us x squared minus 6x minus 6x plus 36. Then we form our two groups. First group we take out x, and we get x minus 6. Second group we just write down x minus 6, and we see that if we take out a minus 6, we'll be on our way. And then you can pretty easily see this will be x minus 6 times x minus 6, or x minus 6 squared. So our up here we can rewrite this as x minus 6 squared minus 49 squared, y squared, excuse me. And now we've got our simple a squared b squared scenario. So x minus 6 times x minus 6 is your a squared, and 7y times 7y is your b squared. So we'll get, I'm going to use two different kinds of sets of parentheses so it's not confusing. But we'll get x minus 6 minus, or plus 7y times, so that's a multiplication symbol, x minus 6 plus 7y. So again, it's like a is the whole expression in parentheses x minus 6, and b is 7y. So you see that we have a plus b times a minus b. Oh, I did a plus in between. Excuse me. Difference of squares. So this should be minus 7y. So right, we have this minus 7y. Oh no. Undo that. Minus 7y. So yeah, so a plus b, a minus b, we have our difference of squares. And that will bring us to some of these more complicated ones. Actually, this is our last problem. There's a few of these on the homework. Nothing so complicated on the test yet again. But it's good to have practice to have these harder problems. So what are we going to do? Well, we're going to take out the smallest power that we see in common. So in this case, the smallest common power is going to be x plus 3 to the 1/2 power. And what is that going to leave us? Well, x plus 3 to the 1/2 power is going to be 1. And then we need to figure out, okay, we need to add some copy of x plus 3 to some power that's going to make us get to x plus 3 to the 1/2. And that actually just turns out to be the power 1. And the reason for that is, let's just check. If we multiply back through, we'll get what we wanted. You'd get x plus 3 to the 1/2, and then you'd get minus x plus 3 to the 1/2 times x plus 3, and that's really to the first power. So since those two things look alike, our rules from section P2 tell us we can just write it as x plus 3 to the 1/2 plus 1 power, which is really just equal to x plus 3 to the 1/2 minus x plus 3 to the 3 over 2. Remember, 1 plus 1/2 gives me 3 over 2. Let's try one more hard one. I can't help myself. This is the last problem in the section, but I know there are some more difficult ones. So let's do one more like 8. So let's just make a new page. And let's say, let's go ahead and factor let's say something like x plus 1. Let's make it really tricky. Let's say to the negative 1/2 plus 7 times x plus 1 to the 5 over 2. And then we'll also add the caveat, because they do this in your homework. Write the answer with only positive exponents. So we have to use that rule that puts it on the bottom in case somehow our final factorization has some negative exponents. Okay, so we start by taking out the smallest power of the factor that we see. In this case, that's just going to be x plus 1 to the negative 1/2. And then we got to figure out what's going on. So we're going to have 1 for the first factor, and then we're going to have plus 7, and then we're going to have x plus 1 to some factor. But we don't really know what the factor is. We can check and see if maybe we got it right like we did last time just by leaving it alone. So if you would multiply this back through, you'd get the first factor, but then what would happen when you do the second factor? Well, we get negative 1/2 plus the first power, which gives us positive 1/2. So that doesn't quite work out. So what I'm going to do is I'm going to put a capital A here as a placeholder, and then I'm going to try and figure out what capital A should be, and that'll give me my factorization. So, oops, too far. So to get the factorization, what's going to happen when we multiply everything back out, when we multiply this thing through? Well, for the second term, you're going to end up with when you multiply x plus 1 to the negative 1/2 times the 7x plus 1 with our placeholder exponent, to figure out what power we're going to have of x plus 1, you're going to get negative 1/2 plus a, because we're going to add the exponents. And then we need to figure out what that should equal. Well, it has to equal exactly what we had on the top, which was 5/2. So we come back down to the bottom, and we set that equal to 5/2. And then we just solve for a, and we replace that placeholder with the number it ought to be. So add 1/2 to both sides, and you'll end up getting a equals 5/2 plus 1/2, which equals 6/2, or 3. So we can come back up here, not lasso, I want eraser, erase the a that we had, and then go back and just replace that with the power of 3. And so now we've got our factorization. There's just one more step, because right now that power is negative. So what we're going to do is we're just going to write the big thing in brackets on top, 1 plus 7 x plus 1 to the third. And then on the bottom, we're going to divide everything by x plus 1 to the positive 1/2 power. Because when you put it on the bottom, the exponent changes signs. All right, well, that's it for my favorite section, P5. I hope you enjoyed that. I know I did. That last problem was especially fun. But I'll see you in P6. All right, bye.